x minus 3 divided by x minus 3 into. Last time we stopped here for we were finding the domain of the function. Here see, this function x f of x is not defined at x equal to 3 and x equal to 1. If I give f of 1, it is not defined at f of 1 and it's not defined at f of 3. If I give values of x equal to 3, here this will become 0, this will also become 0, which is 0 by 0, which is indeterminate form, which cannot be, we cannot say anything about this function at this point. And what about 1? Here it will become 0 and here it will become some function. It will be 1 by 0, which is also not defined. So while we are finding the range, domain, DOD, I will mostly use DOD. DOD is the domain, the maximum number of real numbers at which the function is defined. So we will say r minus 1 comma 3. This is the DOD, domain of this definition. For finding the range, what we will say, first we will remove, since we have said that x not equal to 3, I can place this function as y equal to x minus 2 divided by x minus 1. I will remove these 2 points, this linear function and this linear function, because I have said that x not equal to not equal to. Okay, now everyone has come. Okay, I have said I will remove this x equal to 1 and x equal to 3 points. Now DOD, hello Thorajax, am I audible to you?
Yes, sir.
Check, can you see the screen?
Yes, sir.
Okay, fine. DOD for this function f of x equal to x minus 2, x minus 3 divided by x minus 3, x minus 1. DOD for this function is r minus 1 comma 3. It's not defined at x equal to 1 and x equal to 3. And range for this is, I will remove this and this, since x is not equal to 3. So x not equal to 3, or we can write here x not equal to 3 and x, I can write this. Is there anyone else coming? Rajal Gandhi. Is there anyone else joining? See, I have to repeat again. We have this function f of x, which is x minus 2, x minus 3 divided by x minus 3, x minus 1, and we are finding its domain and range. For domain, or DOD, we say it's defined for all real numbers except x equal to 3, x equal to 1. So I have removed those two. For range, I will remove. I will cancel this x minus 3 and x minus 3. Why? Because I have removed, for domain, I have already removed 3 and 1. X not equal to 3 or x not equal to 1, we can write. So now we can find the values of x. I'm going to next page. y equal to x minus 2, x minus, no, x minus 2 divided by x minus 1, minus 2 divided by x minus 1. Now I will multiply this here. Yx minus y equals to x minus 2. Now shift this here x, x equals to y minus 2. If I am going fast, you can say, or you can type this here. Now I will take this x common, then it will be y minus 1. Here it will be y minus 2. X equal to y minus 2 divided by y minus 1. Now, for this range, you can say r minus, we will remove this y not equal to 1, r minus 1. But since x is not equal to, x is not equal to 1 and 3, I will check these points also. X not equal to 1 comma 3. So I will check if my x if my x is 1, then I will check what is the value for y it will be giving. Y minus 2 divided by y minus 1, which is y minus 1 equals to y minus 2. Y and y will get cancelled. Minus 1 equal to minus 2. This is absurd condition. This I will not remove. This point I will not remove. Otherwise, it is already. I will not remove this point. Okay, this was 1, I guess. Minus 1, sorry. Okay, second point I will be checking for 3. I will give value of x equal to 3. Then I will check what is the value of y. Y minus 2 divided by y minus 1. Then it will become here 3y minus 3 equals to y minus 2. Now 3y, shall I write here? This will become 2y equals to 1. Y equals to 1 by 2. If I get some real value for y, I will remove that point. So I will remove this. So range for this function will be r minus 1 by 2 comma 1. Is this clear? I will write a note. If you want to write this example, you can write and let me know if you have finished writing. Here we have, if we have absurd condition, we will not remove. We will not remove that point from range. If we have value of y equal to some real number, we will remove that point. At that point, we checked here at 3. We got value of y 1 by 2. We will remove this point 1 by 2. Why are we removing that? I will answer in next slide, and I will write a note also. Are you done with writing? Okay. You have doubt? Shall I move to next page? Otherwise, you can do just screenshot this. Okay. This was our r minus 1 comma 3 domain of this function f, and this was r minus 1 by 2 comma 1. Why we are removing this 1 by 2? See here, if we give value of 1 on that point, we are not getting any range here because this was not defined at point 1. When we are giving value of 3, it's coming 1 by 2. If we are giving here value 3, but the function is not defined here. So this, if there is this 3 is not in the domain, then how can we assign it to some point here in the range, in the codomain? Is this clear? Codomain will be R only. Range is this, domain is this, R minus. So 1 is not here. Now we have identical functions. Two functions f and g. F of x and g of x are said to be identical if first DOD of f equals to DOD of g. Domain of definition, or we can say domain of f equals to domain of g. Second, range of f equals to range of g. F of x equal to g of x. For all x belong to DOD. For all x belong to DOD. First, the domain of function f should be equal to domain of function g. Second, range of function f should be equal to range of function g. And third, f of x, the values of f of x equals to the values of g of x for all x belonging to the domain. Is this clear? I am not getting any responses. Okay, let me give you an example. Example 1. Okay, f of x equals to x and g of x equals to mod of x square, square root of x square. Are they identical? And DOD is R. Domain of definition for this function is R. Are they identical functions? How will we check? We will check domain. What is the domain for this function? R. What is domain for this function? R. So first condition, domain of f equals to domain of g, it holds for these two functions. What about range? Now range, what is the range of this function? It's R. It can take all negative values as well as positive values. Okay, I will move to next. One function is this, f of x equal to x. Second is this. Okay, I will use color. And we want to park our car there. Now the rules for parking is, if you place it for 1 hour, they will charge 30 rupees. 1 hour equals to 30 rupees. Okay. If we stay there for up to 3 hours, then they will charge 70 rupees. And if we stay there for more than 3 hours, then they will charge this 70 plus 30 rupees per hour. 25 rupees per hour. Okay. How many hours we are here? Now, how to write this function? Since it will start from 0 to 1 hour, or we can say from 1 hour. If we are there for few minutes, let's say 20-30 minutes, they will consider it as 1 hour. If it is 1 hour 1 minute, they will consider it as 2 minutes or 2 hours. Okay, so for these type of functions, we will be having multiple branches. I will go to next page. For the same function, how will we write this? F of x equal to 30 when x is less than equal to 1. Then second was 50, I guess. 70. X less than equal to 2. If we 50 or 70, whatever you want. I have written earlier 70. I will write here. 70. Then if we stay there for more than 3 hours or 3 or more than hours, then it will be this 70 plus x minus 2 into 25. When x is greater than, this will be the function. And this is called a first branch, second branch, third branch. And this type of function we call piecewise function. It's defined separately for separate domains. Is defined separately for separate domains. For the domain less than equal to 1, it's defined as this 30. And for the domain x, okay, oops, here I have to make one more condition. 1 x is greater than 1 and less than equal to 2. Okay. For this, from 1 hour to 2 hours, it's defined as 70. Then for greater than 2 hours, it is defined as 70 plus x minus 2, where x is number of hours. What will be if what will be f of 1? Find f of 1. Find f of to find f of 3. Find f of 5. F of 1 will be 30. F of 2 is 70. What is f of 3? Otherwise, I will write here k, whatever you want. What will be f of 3? This 70 plus 3 minus 2, which is 1. 70 plus 25, which is 9. What is f of 5? 70 plus 75, it will be 140. F of 10, find this, and f of 12. Find f of 10 and f of 12. Okay, now we have next topic, algebra of functions. Algebra of functions means addition of functions, subtraction of functions, multiplication of two functions, and we have division of two functions. Any doubts so far? Okay, I will give you first one more example for this. What is this? How will we write this function? X minus 3 when x minus 3 is greater than equal to 0, and 3 minus x when x minus 3 is less than 0. Or we can also write this as x minus 3 when x is greater than equal to 3, and 3 minus x when x is less than 3. This is also piecewise function. Oh, sorry, this is mod x only. X minus 3 will be mod x minus 3. I will write here. And is this clear? Algebra of functions, let f of x is defined for, otherwise you can say like f only for smoothness, easy. F is defined from x to r, and g is also defined from x to r. Then we have f of x, x plus g is defined from x to r. F plus g written as like this, then we can write f of x plus g of x, or all x belongs to x. Second, we have here domain and range should be equal. domain should be definitely equal. Then we can do this addition. Second, f minus g of x. How we write it? F of x minus g of x for all x belongs to x. So f into g of x can be written as f of x into g of x for all x belongs to both f divided by g of x equals to f of x divided by g of x for all x belongs to O not R. This is per domain. And here one more condition, g not equal to 0 and g of x not. This is clear. Algebra of functions holds on them, and they should be having common domain. Let's say we have one example. Example one, f from minus 4 comma 3 to and g is from minus 2 to 1. F of x is what will be f into g of x, and what will be f by g of x, and are all defined. F plus g of x will be. First, we will find the common domain. Here, see, we have minus 4 comma 3. We will take their intersection. Then we will make them, their common domain will be minus 2 comma 3, where g is already defined. We will take their intersection. The common domain is minus 2 comma 1. And on them, we can define their addition, their subtraction, their multiplication, their division. And also, for division, we have to remove 0. Then we can define. Is this clear? I hope this is clear. Was our function x f of x is dx, g of x is x square, f plus g of x will be nothing but f of x plus g of x on common domain. Common domain is minus 1 comma 2 by 2 comma minus 2 comma 1 minus 2 comma 1. So this is 3x, then this is x square. So our f plus g of x is this function 3x plus x square. F minus g of x will be done as f of x minus g of x is nothing but 3x minus x. F into g of x nothing but f of x into 3x into about f divided by g of x. Here we will remove also 0 because g of x is not g of x is 0 at x equal to 0. We will remove that point. So for common domain it will be minus 2 comma 1. Minus 2 comma 1 minus 0 for this function to be defined. So otherwise it is not defined. F of x by g of x to 3x divided by 3x divided by to be e by x and x not equal to 0. And we can also say x square not equal to 0. G of x not equal to not here x not equal to 0. Is this clear? I hope it's clear to everyone. Now you can solve all those three sheets which have been given to you earlier. DPP1, DPP2, DPP3. Try to solve those all. And those are okay. We have, let's say we have, it's a relation. Let's say f of x is a relation. We have 3x. X square plus 2 and x is less than equal to 2 and 7x and x is greater than equal to second g of x, which among these are is the function. These are the relations. Check whether these are functions or not. And I have one more. will write here 9x. Is first function f of x is this function. If we write the graph of this function, 7x is nothing but it will reach here. At 0 it will be 0, then it will go like this. At 1 it will be 7, at -1 it will be -7. And what about this 3x square plus 2? But this function is from greater than equal to 2. Check whether these four functions are functions or not. We'll check if any point in the domain has more than 2 points in range. Keep just yeah, you can ask if you have any doubts or questions.
We can solve DPPs now, sir.
DPP 1, 2, 3. For first function, check. Okay, these four functions are okay. I will write here one more. 1 less than equal to x less than equal to 2, and let's say this is x cube. 2 less than equal to x less than equal to 5. 1, 2, 3, 4. These four functions are for homework because time is running out. Try to find. You have vertical line test already, and next class we will start our class from 1 and on to functions. Is this clear? Is there any doubt from this class? Any doubts from previous classes? Hello, Kushi. Kushi, are you there? No. Vajaksh, do you have any doubts, Kushi? What about Thoyajaksh? Harshit, do you have any doubts?
No, sir.
Okay, what about? Okay, then see you in the next class. Bye.
Hey, Bhagya.